All right, this is going to be AP Calculus Self-Check 3.1 Solutions. So girls, we're paying attention?
Yes.
All right, let's talk about number one. Again, we had to make the change to number one so that it made sense. We had to say on what intervals is f prime increasing.
Yeah.
Well, before I even talk about that, I need to talk about why I needed to change that. So if this was just a graph of f prime and I asked on what intervals is f increasing, so heights here represent what on this graph of f prime? They represent f prime. And f prime is, in comparison to f prime is what? Is it the slope, the concavity, the height?
It's slope. Height. It's slope on the graph of f.
On the graph of f, and I'm looking at f prime is what in terms of f?
I don't.
Slope. So, okay, say I gave you the graph of f, and it looked like this. Then I'm saying, where can I look at f prime? Where does f prime exist? F prime exists at slope. This is f prime.
For the graph of f.
This is f prime, exactly.
So on a graph of f is slope, or f is height, f prime is slope, f double prime is concavity.
Exactly.
So then on a graph of f prime is height.
Yes.
So could we just say that, like, if it's a graph of f prime, like whatever graph it is of, that like
You start
is
at height?
Yeah, you start at height.
Yes, and that's exactly what I've been saying over and over again.
Whole time.
That makes so
That
so
makes
if it
so
was,
much
if it
more
was a graph of
sense.
f double prime, then f double prime would be height.
Exactly.
Oh my god, my whole life is a lie. I'm just kidding.
So, all right, so if I was asking where is it increasing on the graph of f, that means I have to have a positive slope. Would you agree? I can't be increasing unless I have a positive slope. So over here, I have a negative slope. But over here, I have a positive slope, and I'm increasing. So increasing was the definition. It's where f prime is greater than 0. It's where f prime is positive. Look, we have a graph of f prime, so what needs to be greater than 0? Height, concavity, slope? Height. Height needs to be greater than 0. Where is height greater than 0? Between -2, oh, it is there, never mind, -2 and 3.
Yeah.
Well, it should have been, well, I was going to say -2 to 1, and then 1 to 3. Would have been the formal answer, but -2 to 3, I guess that's close as we can get.
Why would you include -2 and 3?
Because this is a graph of f prime, so if there is a point here, that means that the slope was indeed 0.
Oh, okay.
But I thought you were asking for f prime, so you were looking for slope. That graph of f.
Yeah, we were looking for slope, exactly. And this is a graph of f prime, so in this case, we're looking for heights.
So like, if it's a graph of f prime, then f prime is height, and then f double prime is slope, and then f triple prime is concavity.
Yeah.
So like, it always starts with height, and height is slope. Yeah, height, slope, concavity, and then like height is like what they give you, like the graph of f prime, and then like.
Well said, yeah. All right, and just go by the definition.
More sense now.
F prime is greater than 0 is increasing.
So you could be more accurate on that, because that's why I was kind of confused, because it does like touch 0.
So that's
But,
yeah,
like-
because like we've been doing separate.
Yeah.
Yeah, so this is as close as we can get. I agree. If you want to be technical, 1 is not included. AP test doesn't really think about that. It just goes for it.
I like Dave.
All right.
Me too. I was thinking.
Moving forward to number 2. All right, the function f is defined on the closed interval 0 to 8. The graph of the derivative is shown. Remember, this is the graph of the derivative. F prime. F prime. How many points of inflection? Okay, inflection point. IP. What is the definition?
Wait, so this is the graph of f prime.
This is the graph of f prime, yeah. Say it again, Joy.
F double prime is 0. Or it doesn't exist.
Ooh, close. So that's, okay, so let me write this down underneath this, because that is still really important. F double prime equals 0. That gives us the possible IP. But it's not an IP unless something very specific happens.
Kind of derivative.
It's something about the derivative. F prime,
Yeah, you're taking the derivative of f prime.
definition of inflection
Setting
point.
it to 0.
I mean, you're using the second derivative test, which is correct, but we didn't actually classify it as an inflection point unless something very specific happened. Unless it
F
changed.
double prime is equal to 0? Wait, oh.
Unless f prime changed from what?
So F prime is talking about height.
Changes sign.
Changes sign. Thank you, Isabel.
So is that talking about like when the height goes from like something positive to something negative?
So, hold on. Go away, you. All right. Before I even move on, do we understand that this is the formal definition of inflection point? It's where F prime changes sign.
Yeah.
We need to have that memorized.
Like whatever F prime is on that graph, that's what the IP is.
Okay.
So it could be slope or height.
No, it's something very specific. So this is the graph of F prime.
No, like on this graph it's specific, but like
Yeah,
in general.
because for this graph.
Yes, you,
sign
no,
is
I see what you're saying.
fine.
Yes, it
Okay.
can be one of those many things. So in this case, height represents what on this graph? F prime or slope of the original F. Okay. F prime would be the formal answer that I'm
Wait,
looking
I thought it
for.
would be height.
Yeah, that's what I said. What is height? And they said
Oh.
F prime.
Oh, okay, sorry.
And then
I'm just confused.
where does it change sign? Where does this F prime change sign?
At 6.
At 6.
Because height switches over.
Exactly.
So then,
But what about 4?
So that's a great question. Inflection point is technically where F prime has a sign change, and it doesn't change signs at 4. So I would not consider 4 to be an inflection point.
look at your answers, Mr.
I'm looking at the answers. That's making me doubt this rule. Maybe this is a bad question. I need to ask my mentor about this question because I have a feeling that the correct answer here is 1. Am I forgetting endpoints or anything? I don't know what I would say that the correct answer is 1, and that's not on here.
I thought it was at slope, so I said there were 6.
Yeah, see. But that was.
1,
like at
2,
the top.
3, 4, 5, 6. Yeah, it changes. So
But we know that that's wrong. Like, I was just confused about what the graph is.
So what you're finding is the change in slope. Wait. I think I have the wrong definition of inflection point.
It's
Oh.
concavity.
I literally just like locked that in my head.
Yeah, like, I
And so,
feel like
like
I
I
was
feel
just
like
like-
it's in there.
I apologize. It's not where F prime changes sign, it's where F double prime changes sign.
Oh, what
We
my
said
God.
that like.
Oh, yeah, I feel like we should have, like.
Just kidding.
And where F prime is equal to 0, that is a possible inflection point. Sorry. So with this correct definition, now we can actually get the right answer.
She said we're F.
Okay,
F
F
prime in this case is slope.
F prime in this case is slope.
So we did right,
We got
Kayla.
it right! Woohoo!
So it changes slope where it is equal to 0 in this case.
What song do you want?
So it changes 1, 2, 3, 4, 5, 6. If you chose 6, you are correct.
We should do our keys and get a chance.
All right, so sorry. Make sure that this is locked in. Inflection point is where F double prime has a sign change. So let me ask the question now, what is F prime sign change? What is that?
Heights.
Yeah, we had it.
That's a CV.
Ooh, close. It's more specific than a CV. CV is just where F prime is equal to 0.
Relative extrema.
Relative extrema, there it is. Relative extrema.
Can I tell you what happened the other day? So we
Perfect.
Wait, equals what?
Relative extrema is where F prime has a sign change. A critical value is where F prime is equal to 0.
The way she said.
Because, like, you know how that guy.
All right.
Like, guy in Richard had a really, like, rough, like, voice.
Are we ready?
Yeah.
All right. Number 3. So here's the graph of the derivative. This is F prime. So we're finding the following that could be a possible value of F. All right. So what do we know about this graph? What does this tell us right here?
That's a CV
It is a CV. Why is it a CV?
because it changes.
X equals 0.
It's a relative extrema.
So
Height changes.
so you said CV. So what's the definition of CV, Sophia?
F prime equals 0 or F prime equals DNA.
Equals 0 or D and E. Perfect. And
No, it's
look,
not,
ooh,
because
that's
of
too
the-
many lines. Yeah, D and E. And this is where F prime is 0. The height is 0. So that's why it's a critical value. This is also a critical value. And Sophia, you also said it's a relative extrema. I agree with you. Someone, and it can be Sophia, but someone in the class, tell me why this is a relative extrema here.
It changes its sign.
Changes its sign, exactly.
So it happens to be a CV and a relative.
And specifically, what type of relative extrema? It goes from a positive to a negative.
So
Max.
Positive to negative is a maximum. So we know that at -1 it has a max. So we know max at x equals -1. And therefore, this one has to be a what at 1? Minimum at x equals 1. Perfect. So this one has a max at 1, -1, and a minimum at +1. This one is reversed, and none of the other ones are even close.
I got it. I totally guessed right.
Oh my
you
gosh,
guessed
wait,
right.
wait.
I guessed, but like.
So the graph of f then would be the derivative of that?
So this is the graph of f. This is going backwards. So the derivative of this graph, b, is the graph that's given.
I don't like going backwards.
Okay.
All right. Questions on number 3 before I continue?
No.
All right. Number 4. The graph of y equals h of x, we don't know what function, is shown above. Which of the following could be the graph of its derivative? All right, so let's analyze this graph. What happens right here?
There is this 0.
The slope is 0. That means what is equal to 0?
CV. F prime.
F prime is equal to 0. And down here, again, what do we have? What is equal to 0?
F prime.
F prime is equal to 0. Oh gosh, my pen is dying. F prime is equal to 0. All right, so that means if I'm looking at our new graph of h prime, what should be 0? The slope, the concavity, the height? What am I looking for down here? The height. So where has, or which of these graphs has a height of 0 roughly in the same points?
Wait, why wouldn't it be slope equals 0 because f prime, if it's graph of x? Wait, is this the graph of x?
This is the graph of, think of this as the graph of f. These are the graphs of f prime.
Yeah, so wouldn't it start out with height and then go to slope for f prime one? Because it goes height, slope, concavity.
So say that again.
Wouldn't it start out, if it's the graph of, going from the graph of f to f prime, you'd go height to slope? So you'd be looking for slope.
So it's reversed. So if I'm looking at the graph of f, the slope here represents the height here. The slope is 0, f prime is 0. That means f prime, the height, will be 0. So there's actually 3 graphs that have a height of 0, right? B and A are eliminated, but all C, D, and E all have a height of 0 roughly at the same points.
C is a negative.
Ah, yeah, now we, exactly. So this is a positive cubic. So this is a positive cubic, which means if I take the derivative, it becomes a what?
A positive.
Positive quadratic. There it is.
Are we gonna need to know that for the test?
Yes, you will.
Are you serious?
Yes. There's a reason that I taught it to you. It's not so that you can forget it. It's like a cubic turns into a quadratic. Something x to the cube turns into something x squared. So this is a negative cubic. Negative again points to negative, and positive points to positive. So it's not negative, it's positive. And this one isn't even a quadratic. Quadratic means it's a U shape or an N shape. It's either, what do we say, a smiley face or a rainbow. Those are quadratics. So it can't be D either. So the correct answer here is E.
I only got that one because I saw it was positive.
Again, positive quadratic goes from the bottom left to the top right. This is positive. If I straighten out the line, it went like this. And a negative quadratic would go with a negative slope. This is negative. All right, question, Kaylin?
So you found that where f prime equals 0, where slope equals 0,
Yep.
and then you know that there has to be 2 spots where height equals 0,
Exactly.
and then you know that's cubic, and then it's positive. So then that's what you did.
Yeah, it was a positive cubic. Derivative is a positive quadratic,
The
which
part I don't
eliminated.
get is how do you know that you're going, like I know that you're talking about slope, but how do you know that you need to talk about height next and not like concavity? Like,
So, okay, yeah, so good question. I'll try to address that now. And the question again was, how do you know that you started with slope and then you need to go to height, right?
yeah.
So I know that the only thing I can analyze here, if I analyze height, that's great. I can analyze slope and I can analyze concavity. All 3 of these things exist in this graph.
Okay.
So the question then becomes, well, what can I see in the graph of f prime? If I'm looking at the graph of f prime,
How do you, and then you just know you're looking at f prime because it says h prime of x.
yeah, I'm talking about h prime of x, h prime. So I'm looking at the graph of f prime. What 3 things can I look at? In here, I was able to look at, and I should do this in a different color, I can look at f, which is height. I can look at f prime, which is slope, or I can look at f double prime, which is concavity. What can I analyze here? Can I analyze f?
No.
No. Can I analyze f prime?
Yeah.
Yes. Can I analyze f double prime?
Yeah.
Okay. So I either get to choose. So I can't even look at f because that doesn't correspond to anything on here.
But it's a graph of f. Oh yeah, that makes
So I went with the next best thing, which is apparent in both graphs, which is f prime. F prime on this one happened to be what? Slope, concavity, height. F prime is
Height.
on a graph of f,
Slow.
it's slope. On a graph of f prime, that turns into
Height.
height. That's why I went from slope to height. It's
So
whatever
all
information I was
of it is
able to
like
give.
Slope, height, concavity.
Yes, it's the same order over and over
I thought it
again.
was height.
Oh, sorry. It goes, yeah, sorry. Height. Height
Slope,
is f. Then it goes to slope.
height, slope,
If I take the derivative of height, I get to slope. If I take the derivative of slope, I get concavity.
You good?
All right. I think we need to move on.
Um,
All right, number 5 out of 6. Which of the functions sketched below is increasing at a decreasing rate? Again, all of these are functions, so all of these are graphs of f. So what does it mean to be increasing? Definition of increasing.
increasing the height.
Increasing, the formal definition that I've given us. It's on the top of most of our homework. Quick little definition, increasing.
I'm looking at my homework.
F is greater than 0.
Close.
F prime
There it is. F prime
is greater than 0.
is greater than 0. That's the definition of increasing we need to memorize.
and it's always f prime.
It's always f prime. This thing is static. This is in stone in our brains. Increasing f prime is greater than 0. It's at the top of most of our homeworks.
Well, oops.
And then rate would be the slope.
So what is the rate of the slope?
It's how much is increasing or decreasing.
That's a good way of analyzing it. So in terms of f, f prime, and f double prime, if I take the derivative of f, I get to f prime. If I take the derivative of f prime, I get to f double prime. We can all nod our heads yes?
Yes.
All right. So the rate is also the derivative. The rate of f is the derivative. That means the rate of the slope is
F double prime.
f double prime. So at a decreasing rate means f double prime is decreasing. Just normal increasing means f prime is increasing. And the English here is a little bit hard to get around, and I can sympathize with you guys. This is saying that the rate is increasing. Wait. Let me make sure I got that right. I'm reading this as the rate is increasing at a decreasing rate. Maybe that should be backwards. I'm struggling with the English, not the math of this. Which of the functions sketched below is increasing at a decreasing rate? So I'm interpreting increasing as the rate, and then this is the rate of the rate, which is the double derivative.
So decreasing means what?
So decreasing means it's less than 0, but this, how I analyze the structure of the sentence, decreasing rate, I'm assuming that that means that the rate of this rate, the rate of the rate is the double derivative. All right, so where do I have f prime is greater than 0 in these 5 graphs?
Which is
A
slope or height?
What is f prime? This is all of these are graphs of f.
So it's slope.
Slope. Where are these have a slope that's greater than 0?
I think if you don't say it, it's just
Can't be B, can't be D, can't be E. Now, which one has f double prime less than 0? C. This is a concavity down.
because it's sort of arcing.
Okay, I got
outwards.
this in a totally weird way, but I was like increasing, which is like going up like at a
I
slope.
got this wrong.
But then it's like decreasing, like going, like it's starting to go
Yeah, that's what
slower.
That's a good way.
So
No,
it's
that's a perfect way to think about it. I'm using the definitions here to make sure that everyone can analyze it, but that way of thinking about it is totally correct too. It's increasing, it's going up, but at a decreasing rate, not going up as fast in the future. Perfect. All right. Can I go on to number 6? Or do we want a little bit more time to digest?
No, I think we're good.
All right, last but not least. Okay, this is a graph of f prime. So it says that there's horizontal tangents here, here, and here. So at which of the following values of x do I have a relative maximum? So maximum, definition of maximum. This is set in stone. What is this?
Positive to negative.
What goes from positive to negative?
F prime.
Perfect. F prime goes from positive to negative. Okay, this is a graph of f prime, so am I looking at heights, slopes, or concavity? Heights. So where does the height go from a positive to a negative?
-1 and
Yep.
No, because you're looking at height.
Height.
So then it would be -2 and.
I think just 4.
But
No,
then
-2,
that one's
1,
going to
and
plus
4.
to minus. Which one's going up? Which would just be -2.
Yeah, so I mean, the only time that I change signs is where I cross the x-axis. So it's either here or both.
It's just 4.
And it's just 4.
Dang.
Because on 1 it doesn't actually go under. Is that what it is?
So at 1, yeah, it doesn't change signs. It doesn't go to negative. It has to go from positive to a negative. It stayed positive. It went from positive to a positive. So this one went from positive. Okay, my handwriting is getting a little bit bad there. This one went from a positive to a positive. That's not a positive to a negative. All right. Do we learn some things? Get some good review?
What about between -3 and -2?
Negative 3, yeah. So between -3 and 2, so at -2 here, that went from a negative, down here is a negative, to a positive. A negative to a positive is a what? That's a min. All right. We have our answers. Are there any last questions on self-check 3-1 or 3.1?
No.
All right, go ahead and put that away. Get ready for self-check 3.2.